Okay, welcome to week 7. We're going to take a look today at some ideas about visualization and storytelling with data. Let me get going by. We're going to take a look here at just some ideas about useful visualizations. Here is yet another form of maps. This map does not attempt to be accurate as far as the the outlines and so forth of the various states in the country, but each of the states here is represented approximately where it is located relative to other states. And this sort of fanciful image is indicating what the most searched recipe is for Thanksgiving in each of these different states. The color scheme here is unwonderful, I would say, because it's relatively difficult to tell some of these colors apart from each other. But this is a kind of whimsical Thanksgiving thing. So what we see here is that apple pie is very popular in the Northeast and also in Alaska. Pecan pie is very popular in the South. Pumpkin crunch appears to be the popular thing in Hawaii, if I'm recognizing the color correctly, and pumpkin pie in the Midwest and the West. Then we have people looking for stuffing recipes in Delaware and sweet potato recipes in Illinois. I'm not sure. Again, I mean, this is just kind of a whimsical thing. Might show up in a newspaper or something. Here we have similar kind of representation of this using a pie chart and these bar charts split up by regions. Pie charts are interesting if there's a distinct difference in size between the different categories. We see here that searching for pumpkin pie is more than half of the total searches. In a pie chart, if the different slices are similar in size, then the pie chart is not precise enough in all likelihood to give very good results. And in that case, you're probably better off taking the pie chart and representing it instead as a bar chart, so that it's easier to tell apart the precise differences in the lengths or heights of the bar chart. Lengths in the case of a horizontal bar chart, or heights in the case of a vertical. Here we have split out by category what the popular searches were in various different regions, with apple pie being the most common search in the Northeast, and pumpkin pie in the Midwest and the West, with pecan pie in the South. Here is yet another sort of fanciful representation of popular main dishes, side dishes, and desserts. I'm not going to read through this particularly. This is from 538, which is a very well-known statistical analysis website. They, in particular, are known for doing political analyzing political polls to try to make predictions about elections. But here, again, we've got a sort of fanciful Thanksgiving thing going on. I should mention, by the way, these are not intended necessarily as direct Python-based things. These are just some ideas about doing representations in graphical form. These things are actually produced, if you can see this tiny subscript, if you can see this tiny text at the bottom, these are actually produced in Tableau, which you will very likely encounter in a future course. Okay. Another example here, we have football games played on Thanksgiving Day. I don't know what else to say about that. Here we have yet another representation of the top pie recipe by state. This time the states are approximately accurately drawn. Some of the sizes here look a little off. I think because of the states being artificially wider at the top than at the bottom due to the ascending latitude. Texas, in reality, is significantly larger than Montana. It just doesn't look like it here. Again, I'm not sure quite what there is to say here. I do notice that this differs from our previous representations. It looks like sweet potato pie is very popular in the South here, in comparison with pecan pie that we saw in the other ones. Here we have a plot of the number of calories per serving on the vertical and the cost per serving on the horizontal. This time representing the different foods with images rather than just plain old ordinary points. And so, it's attractive. It depends on who your audience is, but this might be interesting to someone who's just kind of casually interested in calories and cost of things. Here we have some time series plots for Wednesday through Friday, midweek to the end of so-called Black Friday on day after Thanksgiving, showing the times of relative busyness of different shops. So bakeries tend to be at their busiest around lunchtime on the Wednesday before Thanksgiving. Grocery stores slightly later, liquor stores slightly later, and then that's kind of their peak busyness. Movie theaters tend to be at their busiest on the Friday following Thanksgiving, as do shopping centers, although the shopping centers are pretty busy on the Wednesday before as well. And this is the same information, just with a little bit more annotation. I'm not sure what to say about this one. Yet more colorful, fanciful representations of information. How will you celebrate with family, with friends, alone? Interestingly, these appear to add up to more than 100%. So, take that with a grain of salt, I guess. What does Thanksgiving mean to you personally? Okay. Here is a plot again. I don't know, sort of semi-serious, showing the impact of the COVID pandemic. In the year 2020, all forms of travel were well down compared to the previous year for people traveling for Thanksgiving, and particularly air travel was way down. Whereas in 2021, travel had increased, not to 2019 levels, but closer to 2019 levels. And by now, recently, we've just had a record amount of travel for Thanksgiving post-pandemic. Here's a nice kind of chart showing the flow of what happens to turkey over time that's left over from Thanksgiving. Again, this is probably not something that you can do in Python. I'm not sure about that, actually. And another examples of time series charts. I guess the common theme here is that these are all trying in an attractive and colorful way to convey meaningful information to a certain audience. Here are the impact of inflation over the course of the last, 20 years from 2000 to 2021. And here again we see the dip in travel that occurred during the pandemic, although there's still an awful lot of travel going on for Thanksgiving. And now returning to trend. This is a very famous image produced by hand by this fellow named Charles Minard, who is a French, I'm reluctant to call him a bureaucrat, but he was sort of a engineer slash bureaucrat. And what this image shows, this is regularly touted as one of the greatest graphical representations of information ever produced. This shows what happened to Napoleon's army when they crossed into Russia from Poland in attempting to take Moscow. And the brownish color here indicates how many troops there were in the army on the way to Moscow. And the black part of this image shows how many troops remained in the army in the retreat from Moscow. On the bottom here, what we see is the temperature during the retreat from Moscow, and as you can see, it was bitterly cold. Napoleon started out with over 400,000 soldiers in his army, and by the conclusion of the thing, ended up with only 10,000 remaining. So this is a and horrific campaign. All right, so this is, this kind of thing is what you want to strive for. This is the most well-known of this guy's graphical representations of data, but he actually produced a number of similar kinds of images for various to represent various different things. This one we've already seen. This is Jon Snow's cholera outbreak image that helped the local government officials in London identify a particular water pump as possibly being the source of a cholera outbreak and shutting that down. Okay. So again, these are not these are just various different images intending to represent information of interest to various different kinds of audiences, ranging from fairly fanciful representations to quite detailed representations. One of the primary considerations that you need to make when you're putting together visualizations of data is to decide who your audience is, what will grab your audience's attention, and what will convey the most useful information to your audience in the clearest form. All right, well, let's move on to the idea of storytelling with data. Now, this is not a what am I trying to say? This is not a here is what you do kind of thing in the way that you can talk about technical details about how pandas works and how NumPy works and how GeoPandas works and so forth. These, again, are sort of rules of thumb and guidelines for how we would go about telling a useful story to some audience about some data that we're analyzing. Okay, so what about telling stories with data? Well, as is indicated here, people tell stories, words tell stories, images tell stories. The purpose of a story is that a story is more memorable than just a display of facts or a display of charts. So ideally, you want to construct your images in such a way that they tell a memorable story. Here in the lower right, we have an example of a graphical story about the timeline order of the various Marvel Cinematic Universe films up through Thor: Love and Thunder. There have been some since then. What sections does a story normally have? Well, we have an introduction, a body, and conclusions, a finish. And so this is the same organization that you should follow for any story that you're trying to tell using visualizations of your data. This is an image taken from the New York Times. This is a newspaper graphical story. It is quite crowded by comparison with stories that you might tell using plots created with various Python tools or Tableau or something like that. But this had to fit like on the lower half of a page in a newspaper. It starts out with an introduction section. 755, steroids or not, the pursuit is on. This is about the pursuit by Barry Bonds of the home run record. At the time this was published, he had hit 755, or he was on his way to trying to get past Hank Aaron's record of 755 home runs. Here we have a legend, okay, of the top home run hitters of all time at this time period. Hank Aaron was the leader. He had hit 755 home runs in a 23-season career. Babe Ruth was next with 714 home runs in a 22-season career. And Barry Bonds at this time was in the 20th season of his career and had hit 708 homers. Now, this legend, these colors, black, gray, and red, are used in this graph to plot the cumulative number of home runs that each of these three people had hit according to the season of their career that they were in. Okay? The main part of the story here is the graph showing the cumulative number of home runs for each of these three players over their careers as a function of what season they were in. So here's the first 5 seasons, first 10, first 15, and then here we are out to 20 seasons. What we see, and it's not explained here, Babe Ruth had relatively few home runs during his first 5 seasons. It turns out that Babe Ruth was a pitcher early in his career, and therefore, in that role was a quite dominating pitcher, but didn't really start his home run streak until around his 5th season. Hank Aaron, on the other hand, had a very steady production of home runs all the way up through his 20th season, and then after that, things tapered off for him slightly. Both Hank Aaron and Babe Ruth had careers that looked similar in terms of their home run productions. When they were younger, they had a very steady accumulation of home runs, and as they got closer to the end of their careers, the home run productions slowed down. Now, what's unusual about Barry Bonds' career, and this is starting here at season 14, is that at season 14, his production of home runs actually increased noticeably compared to his prior production of home runs. And I'm sure it's very difficult for you to read this here, but the allegation at the time to explain this change in the trend of his home run production was that he had begun taking steroids. And he was not... I was going to say he was not the only one taking steroids. I'm not sure it's ever been conclusively proven that he did take steroids, but it is almost universally believed that he did. There were other well-known baseball players at the same period of time who were known to be taking steroids, and others who were widely believed to be taking steroids, who had this sudden increase in their performance at a time when many other players' careers were starting to slow down. Okay, and so you can see in this focused in display of this portion of Bonds' career that suddenly his production of home runs actually increased, even though he was at the 14th season of his career. Okay. We've also got some, in addition to that main story and the descriptive information about the main story, we have some other related in-depth information about other players who were active at the time. Hank Aaron, Babe Ruth, Barry Bonds, Willie Mays. These were historical players. Frank Robinson was an historical player, although much more recent history than these other folks. And other players who were active at the time, Sammy Sosa and Mark McGwire, were known to be taking human growth hormone, and in fact were not being particularly secretive about it. This was prior to the time when steroids were known to be harmful, and Sosa and McGwire simply used human growth hormone because it helped their performance. And it wasn't until they were well into their careers that this became a huge controversy. Okay. Ken Griffey Jr. Was a very outstanding player who was thought to be the next person who would probably catch Babe Ruth, but he became injured and his career didn't last quite so long. And other active players at the time included Alex Rodriguez, Albert Pujols, who were also on significant pathways, accumulating more home runs at a faster pace than the historical Hank Aaron and Babe Ruth. Now, it does turn out, okay, so this report was produced in Barry Bonds' 20th season. He did go on to surpass Hank Aaron's record by 10 or 12 home runs. And yet, he has not been, at this point, elected to the Baseball Hall of Fame because it is so widely believed that he did use steroids to achieve this record that he's been not elected to the Hall of Fame. And in fact, likewise, Sammy Sosa, Mark McGwire, other players who got very high total home run numbers have not been elected to the Hall of Fame. All right, so that's that. Again, this is a half page in a newspaper, and so it is rather crowded, but it is doing a good job of telling a story with with an introduction and a main story and some supporting information in the half page of the newspaper that it was allocated to. Here's another plot, and we're asked, why is this graph bad? Well, let's take a look at this. So this is the mean arrival delay time. And in the legend here, we have American Airlines, Delta Airlines, and other airlines. The size of the circles here indicate the number of flights. There are circles of all kinds of different sizes, from very small circles up to very large circles. These largest ones look like they're matching the 12,000 flights. These very small ones aren't really shown in the legend. Maybe these are, 500 flights or 1,000 flights or 2,000 flights or whatever. It's difficult to say. Why is this bad? Well, notice that in the legend, American Airlines and Delta Airlines are sort of singled out as named airlines to be represented in the plot. And we're told that, this is measuring delay time. It's a little less obvious that line there is the zero delay time. So actually anything prior to zero is an early arrival. We might be led to believe that there is something wrong with American Airlines and Delta Airlines on-time performance, but in fact, a more careful reading of this shows that they are actually early a great deal of the time. And they are not as late as some other airlines. In fact, it turns out that American and Delta, of all the various airlines, have the lowest rate of delays. So this graph, well, it's just plain confusing, and it is artificially singling out American and Delta Airlines as though there's some kind of problem with these airlines. A bar graph makes it much more clear that American and Delta are doing extremely well in terms of the mean arrival delay times. ExpressJet is by far the worst, with an average delay time, it looks like, of about 15 or almost 16 minutes late. Okay? American, Delta, U.S. Airways, and United are, in fact, doing very well in comparison to these other airlines. I want to do a shout out here to a particular book that I recommend you have a look at if you have time. This book called Storytelling with Data. The author, this woman was hired at Google to try to tell stories about what was going on with employees and managers within Google, using, I don't know if this was dictated to her, that she use graphical images, but she did end up using graphical images for a lot of this work, and she describes her process for putting tables and line charts and bar charts together in order to convey meaning to people about the processes that were going on. And she very much recommends using bar charts rather than these sort of ridiculous scatter plots with trend lines and so forth that hey, they look cool, but they in fact hide the true story that you're trying to tell. Okay, here we're showing the number of flights. Again, a horizontal bar chart. And we see that Delta and American have a huge number of flights each day. Actually, this must be annual. Okay, well, I paused and checked, and this is neither daily nor annual. It may have just been the number of flights during the period of time that this data set was being measured. This actually looks more like the number of flights per week, roughly speaking, for these different airlines. Regardless, Delta and American do have the best on-time arrival ratings, despite being major airlines with a very large number of flights. Southwest, interestingly, has many fewer flights, and yet also has a very poor, relatively speaking, poor on-time arrival rating. Okay, so one lesson here is that if you do try to show too much data at once, you end up not really showing anything. And this is something to be careful about. It is a temptation to show your audience too much detail about the data that you have gathered, perhaps in an attempt to make an impression about about how much work you've done, et cetera, et cetera. But you're trying to convey meaning to your audience. You're not trying to convey data to your audience. So you want to be careful to show meaningful results in a graphical way, not to necessarily just dump a whole bunch of data on your audience. Here we have another in my view, rather overcomplicated graphic, but at least it breaks down what's going on in this busy lower left-hand graphical image by showing a particular component of the image. What we have here are United Airlines departures from Newark Airport. EWR. These are the New York City area airports. EWR is Newark, for some reason. I'm not sure how you get to EWR from Newark, but whatever. And then we have JFK and LaGuardia. So these are the three major airports serving the New York City area. United and Express jets do an enormous number of flights out of Newark. JetBlue does the most flights out of JFK. Delta, American, and Endeavor also do a significant amount. And then out of LaGuardia, we have Delta, American, Envoy, and U.S. Airways as the primary carriers. So, for whatever that's worth. Okay. So one of the key things to get right when you're trying to tell a story is about the audience that you're trying to communicate with. And a couple of dimensions along which audiences vary are their opinionation level, whether they are neutral to what you're going to say or opinionated about what you might say. And then there's also another dimension is information density, whether the amount of information per minute that you're trying to convey is relatively low or relatively high. All right, so TED Talks tend to be relatively low in information density, but with opinionated speakers speaking to opinionated audiences. A board meeting, on the other hand, these folks are going to be very interested in your story, but they are, one hopes, not going to come in with preconceived ideas about the subject that you're discussing. And they are also going to be interested in results and conclusions. They're not going to be interested in seeing all of your data. I mean, they might ask to see that at some point later, but that's not the first thing they're interested in. Expert panels are going to be both high information density and opinionated, whereas group meetings in a business setting, one hopes, are high information density, but the people in the meeting are not going to have preconceived ideas, one hopes, about what you're saying. All right, so just out of curiosity, where do you suppose the educational experience figures in here? Probably on the high information density side, maybe more opinionated than a group meeting in a business setting, but less so than an expert panel. Okay, so I guess I would slide the education experience a little bit over to the right here. We hope that we don't have low information density going on in an educational setting. Okay. Here is an example. This is a database that is accessible about the stop, question, and frisk actions of the New York City Police Department. The idea back when this first began was that if you stopped and frisked suspicious-looking people, you could reduce crime, you could reduce gun violence. A major flaw here is that, what is a suspicious-looking person? And there was a lot of very obvious and appropriate blowback that this was that this was a very racist kind of policy, with a lot of minority teenagers being subjected to these stop and frisk activities. So, what questions can we ask about this data? What can we focus on in this data? Here are a couple of plots that we can produce from the data. Our question here is, is there some kind of relationship between where people are stopped and the age of these people? Well, here are the boroughs of New York City. Brooklyn has the highest frequency of stop and frisk events. I'm going to assume that this was over the course of a year, or maybe it's over the course of the entire data set. The boroughs, conveniently, are not labeled, but the major boroughs are going to be, and I don't know which boroughs these bars apply to, but we're going to have Manhattan, Brooklyn, Queens, the Bronx, and Staten Island, and I'm gonna assume that Staten Island is this lowest count one over here because it's the most kind of peaceful, suburban, and not very large of the 5 boroughs. But I could be totally wrong. Maybe this is Staten Island and maybe this is Manhattan, whatever. And then we have the age of the people that are stopped, and as you can see, most of the people that are stopped are in the majority are in the 20 to 25 range, but a lot of teenagers all the way down to 10, 11, 12 are also being stopped, and then as people get older, they are stopped less often. Can we see from this that there's a relationship between where people are stopped and the age that they're stopped? No, we can't tell anything. So this data set just flatly doesn't answer this question. Are they answering the question? No. Are they effective? No. I mean, we can't tell anything at all about the likely effect on reducing crime, either from the number of stop and frisk events that occur based in the boroughs, based on which borough they were in, or based on the age at which people were stopped. I guess teenagers look more suspicious to the police than older folks do. It just doesn't really help us at all. This is a very common problem, even where people do collect data. In addition to analyzing data and trying to draw conclusions, it's important that the data being gathered be appropriate for the kinds of questions that you're likely to want answers to. And it turns out very often to be the case that that various groups involved in various processes will gather what they believe is useful data about what they're doing, but then when a trained statistical analyst sits down and starts looking at the data, they realize that the data simply aren't informative about the kinds of questions that a decision maker might be interested in asking. So it's not enough to just gather a bunch of data, like where people were stopped and frisked, what their ages were. The whole thing needs to be more carefully designed at the outset so that you can hopefully get answers to some meaningful questions about the data. Okay, well, that's all I got for that.